Well, hello everybody. So I'm going to go over, this is questions 1 through 14 for our matter and measurements and systems test. So first off, okay, you got to identify which of these are a chemical change. Chemical means they make something new, some new substance, and going through. Tarnishing is a type of rust, so that's chemical. Oxidation is a fancy way to say rusting in oxygen, so that would be 2. Rusting, there we go. And so the rest of those are going to be physical changes, because this and all of these, melting, boiling, vaporizing, if we're working with water, you just add or take away energy. Soda pop bubbling, there's a little bit, okay, there's some chemical change going on there, but also there's a little bit too, there's going to be a little bit of physical, just lessening the pressure. So you got a little bit, because you do have carbonic acid changing into CO2, but then also just releasing the pressure lets some dissolved CO2 bubbles out. So that's not really great. We won't give you one like that. Condensing, okay, that's just like it's a physical change, vapor going, and then we got there. So number 2, how is a chemical change different from a physical change? You get new chemicals made. Example, you could have hydrogen gas plus oxygen gas, bang, it blows up. That's like what they use in some of the fuel for rockets. It makes water. It'll be steam, but that's what can happen. And actually, if we're going to balance this, because it drives me nuts not to have a balanced equation. Let's see, a physical change. Okay, well that can be water freezing into ice. So this is H2O in the liquid state, and this is H2O in the solid state. Sometimes we designate those with an S or an L after them. Oh, I meant to zoom in there. Okay, on this one right here, we have hydrogen gas reacting with oxygen gas to produce water. Okay, that's just what we showed right there. And a little energy released. Okay, I'll put plus energy. Okay. What type of change is this? Well, this is going to be a chemical change, because you are making new substances. You're starting with 2 gases that are flammable, reactable. You're going to end up with a compound water that is very stable, and after it's probably going to be steam, but then it'll probably cool down into liquid. So this is chemical, because you're going from hydrogen and oxygen are combining together to make a new compound. You're getting new stuff, H2O2. Mass is a measure of how many atoms? How many atoms? How much stuff, if we want to be blunt. Grams is a measure of mass. Milliliters, these are a measure of volume, and that's where you get from length times width times height on that one. And grams per cubic milliliter or grams per cubic centimeter is a measure of density. Fill in the equation triangle. The best way, I think, if you draw the triangle, is just remember when you go get a car, if you already have, you had to go to the DMV and just put a little times there, and now you can use this as a nice way to rearrange between different equations. Okay, so this box has a dimension of 4.3 times this times this. What is the box's volume? Well, I'm going to cheat right here because I have it pre-made there. So when you multiply that out, we're going to end up with, let's see, we did that in one of my classes. I didn't get to that one. Okay, the volume came out to be 1,541.8 centimeters cubed. And that's going to be just by multiplying those together. Now let's see, let's see, for this one, I don't know, this is telling us to round, this one I guess is already rounded to 1 decimal place. If the box above has a mass, so what's the box's density? Density is mass divided by volume. The mass is 430. We're going to divide by 1,541.8 cubic centimeters. And the answer we're going to get when you put that through, that's grams, and that's cubic centimeters cubed, excuse me. You're going to end up with 0.278, and we want to round to 1 decimal place. So we got to look at that one. That's a 7. That means we're going to round this to 0.3. Let's see, number 8 here. Sorry about that. So you have 3.1 gram samples of this, iron, and gold. Okay, so for all of these, the mass is 3.1 grams. We have different densities for these different guys, which means if we have, so different densities, calculate their volumes. Well, let's see. We need to calculate volume. Volume is mass divided by density. Volume is mass divided by density. So we've got to do 3 of these little equations because we got 3 different chemicals here. So for the first one, I'm just going to do it in the order we have them here. The mass for all of these is 3.1 grams, so that's easy to do. 3.1 grams. Now we got to divide them by their density because that's what volume is. So for aluminum, I'm going to put Al here, volume of aluminum. We got to divide it by 2.7 grams per cubic centimeter. We've got to divide this one by, this is going to be iron. Now the symbol for iron is Fe. I'm just going to put Fe because that's the symbol. So iron's density is 7.9 grams per centimeter cubed. And over here, this guy here, this is for gold, everybody's favorite element, most people's favorite element. We're going to divide it by 19.3 grams, grams per centimeter cubed. So let's see, we want to round the answer to 2 decimal places. So now it's a matter of putting it in your scientific calculator. 3.1 divide 2.7. Now I know right away this answer is going to be slightly bigger than 1 because this number is bigger. So now we got to round to 2 decimal places. So my calculator, it comes out with that, and I'm going to go to 2 decimal places. So that means I got to look at the third. That 8 is going to make us round this up to 1.15. 1.15 gram, that'll be centimeters cubed. Okay, on this one over here, we're going to do our 3.1 divided by, okay, this is by 7.9. Okay, this answer is going to be smaller than 1 because this number up here is smaller than the denominator. And we get 0.392. We need to look at the third one, and since that's smaller, we're going to round that up to 0.39 grams per cubic centimeter. Okay, the next one over here is we've got to enter in our 3.1. So 3.1, we got to divide that by the density of gold, which is 19.3. Uh-oh, I don't know if I hit that. 3.1 divided by 19.3, and that's going to come out to 0.1606. So we got to look at the third decimal place. It's a 0, so that means we're going to leave that alone. So 0.16. 0.16 cubic centimeters. So I've rounded them to 2 decimal places, and we wanted to rank them in increasing order of volume. Okay, so we want the volume to get bigger. So let's see, our smallest one is iron. Then the next one at highest volume is going to be, oh, I'm sorry, I was incorrect. Gold, which is Ag. Excuse me, no, Au. Wake up. Here, I'm just going to write them out. I'm getting tired. Gold has the smallest volume. The next highest one is going to be iron. And then we're going to have quite a bit with aluminum. For number 9, okay, so it says that you have 5 cubic centimeter samples of these 3 compounds. Calculate their masses with the equation triangle. Cover up the M, and the equation for mass is density times volume. So mass equals density times volume. We're going to have to do that 3 times, density times volume. Mass equals density times volume. So let's see here. So getting these set up. Now we know that the volume is going to be the same for each of these, 5 cubic centimeters. So I'm just going to put 5 cubic centimeters in for all of these. That'll be a little, there we go. And then we got to multiply it by their densities. So 2.7 grams per cubic centimeter cubic centimeters cancel out. This one will multiply 7.9 grams per cubic centimeter. The cubic centimeters cancel out. And then we're going to multiply this one by 19.3 grams per cubic centimeter. Cubic centimeters will cancel out. So we got to multiply those out, and we're going to get 5 times 2.7 is going to be 13.5 grams will be our answer for aluminum. I'll put aluminum there. Over here, 7.9 times 5. This will equal 39.5 grams, which shouldn't, because iron's quite a bit denser than aluminum, so if we have the same sizes of each, we should have quite a bit more mass. And I think I handed around to all of you the aluminum and the iron, and you notice that that great big piece of aluminum was nowhere near as heavy as that one. And gold. So we need to do 19.3 times 5, and you're going to get, wow, almost 100, 96.5 grams. So that'd be pretty heavy. Okay, I'm not going to list them increasing masses. Okay, increasing masses, which means we got to go from small. Well, right now they're in order of increasing masses right here. So if you have a 7,000 gram chunk, that is the mass. And let's see, you've got a piece of pumice, that's a volcanic rock. You might use it to scrape your feet or to clean the pool. That's what the density is. Calculate volume. Using the equation triangle, you cover up the V, and it's mass divided by density. Volume equals mass divided by density. So we're going to put 7,000 grams divided by the density of 0.3 grams per centimeter cubed. Now, when you divide by a number less than 5, it's going to make the number appear quite a bit bigger. And I'm thinking it may just multiply that one by 3, more or less. So 7,000 in your calculator times, not times, we want to divided by 0.3 is going to equal 23,333. And I'm going to round that to 1 decimal place. And that's going to be the grams cancel out, and that'll be cubic centimeters. So let's see, number 11 here. If you have a volume, this is volume, chunk of frozen lava, that means a rock, okay? We got the density for lava. Most rocks are around a density of 3. What's the mass? Well, at the equation triangle, mass equals D times V. Mass equals D times V. Excuse me. And let's see, what do we got here? Oh, plug in the numbers. The density is 3.2 grams per cubic centimeter. We're going to multiply that by the volume, 219. 219, I'm thinking 2, 4, 6. I'm thinking it'd be close to 700. It's always nice to do a quick guesstimate. 3.2 times 219. Uh-oh, I used a naked number. I'm not supposed to do that. 219 centimeters cubed. There we go. Those will cancel out. And let's see, our answer should be, I'm going to double check this one. I think it's 700.8. Let me double check because I got distracted doing that. 3.2 times 219. Always good to double check your calculations. Yeah, I agree with that. Now, that's going to be, since the centimeters, be grams. All right, we're almost done with part 1 here. If you have 3,000 milliliters, that's a volume, of molten lava with this mass, okay, what's the density? Well, density is mass divided by volume. That's our base equation. And we've got a mass of 1,050 grams. I'm going to divide that by 300. Well, I can tell you right now, 10 divided by 3 is about 3, and so since this is 1,000 divided by 300, the answer is going to be, I think, guessed it, or somewhere around like 330. So let's see what it actually is. So we're going to put 1050 in the calculator, and we're going to divide it by 300, and that's going to equal 3.5, and that's going to be, oh, this is cubic centimeter, oh, that's milliliters, excuse me, grams per milliliter. Number 13, the given is 600 meters, so you put that over 1. Then you need to use a conversion factor at the top of your paper. It says that let's see, 1 meter is 1,000 millimeters. Is that where we're going? Oh, we got to go to centimeters. Okay, I think we got a centimeter. There we go. 1 meter is 100 centimeters. So that's our conversion factor. And let's see, so we need to set it up. We want the meters in the denominator and centimeters up here. And so when you look on your sheet, there's 100 centimeters to 1 meter. So we'll put a 100 up there and a 1 meter. You know you set it up right if you cancel out the m's for meters. And when you multiply this, let's see, that's going to be 6 followed by 4 zeros. 60,000 centimeters. How many miles is this? Oh, are you kidding me? So we've got 60,000 centimeters. So we got to convert that to miles. So we're going to put that over 1. So we do have a conversion between miles to kilometers. So now you're going to have to convert centimeters into meters. So I know it's kind of clunky, but I'm going to say okay. We said there was 100 centimeters in 1 meter. There is, when you look up there at the top, there's 1,000 meters in 1 kilometer. 1,000 meters in 1 kilometer. Now let me see, the centimeters cancel, the meters cancel, and then there was a conversion up there at the top that says 1 mile is 1.6 kilometers. So now we're going to say 1.61 kilometers is equal to 1 mile. The kilometers cancel, the kilometers cancel. So now you're going to do 60,000 divided by 100 divided by 1,000 divided by 1.61. Now you can make it easier on yourself if you like. See these 3 zeros there? We could take those 3 zeros and cancel those out. So now it becomes 60 divided by 100 divided by 1.61. I'm not going to cancel any more zeros, so I'm going to go ahead and put in the number there. So I've got 60 divided by 100 divided by 1.61, and I got 0.372. I don't know if we... Now, I'm just going to double check that. So let's say you didn't want to cancel off those zeros. So I'm going to put 60,000 divided by 100. Then I'm going to hit divided by 1,000 on the scientific calculator and divided by 1.61. Okay, got the same answer, and that's going to be miles. Okay, lastly, oh my goodness, this is the last one on here. So we got 60 centimeters over 1, that's our given. And the conversion factor up there says that there are 100 centimeters in 1 meter. The centimeters cancel out, and we're going to do 60 divided by 100. 60 divided by 100. Let's see, that should, okay, well, I'm just going to hit equals there, 0.6 meters. Okay, there's the end of the first page of the review. Finally, yay.